In the vastness of the observable universe, there are places that boggle the mind, regions so strange that even astronomers, trained to expect the extraordinary, find themselves speechless. One of those places is called the Boötes Void, a cavern of nothingness so large that it defies our sense of scale, our understanding of cosmic architecture, and even the limits of our imagination. To understand why the Boötes Void is so unnerving, we first have to appreciate what fills the universe most of the time: galaxies. From our perch inside the Milky Way, we peer out and see billions upon billions of other galaxies stretching across the heavens, each a glittering island of stars, planets, black holes, gas clouds, and mysteries. The large-scale structure of the universe looks almost like a cosmic web. Filaments of galaxies crisscrossing the void, intersecting at massive clusters, forming a network as intricate as neurons in a brain. But then, every so often, you find a hole in the web, a dark pocket where there should be light, an emptiness where you'd expect activity. Astronomers call these regions voids. They're part of the natural tapestry of cosmic structure, regions with fewer galaxies than average. Usually, voids span tens of millions of light-years. But the Boötes Void? That one breaks all the rules. Discovered in 1981 by astronomer Robert Kirshner and his colleagues, the Boötes Void stunned the astronomical community. It lies in the direction of the constellation Boötes, the herdsman, and extends across a staggering 330 million light-years. To put that in perspective, if the speed of light were a passenger car on the interstate, it would take 330 million years to cross from one side of the Boötes Void to the other. This void is so massive that, if you dropped the Milky Way into it, you could line up thousands of copies of our galaxy back-to-back before you reach the far wall. The void contains only a few dozen galaxies in total. That's remarkable because a region of space that size would normally be expected to house tens of thousands. Imagine driving through the United States at night, expecting to see the glow of cities, the headlights of cars, the scattered pinpricks of houses. And instead, after days of travel, you encounter only one gas station, faintly glowing in the dark. That's what the Boötes Void is to the universe. A lonely gas station in the middle of nowhere, surrounded by endless blacktop. And yet, it's not merely the size of the void that unnerves astronomers. It's the questions it raises. How does such a hole exist in the first place? What processes of cosmic evolution carved out such an enormous region of emptiness? And what might we learn about the nature of the universe itself by studying it? To answer that, we need to travel back in time, not with a machine but with light, because when astronomers observe galaxies at the edge of the Boötes Void, they're seeing them as they were hundreds of millions of years ago. Light is a time machine, delivering to us ancient snapshots of how things used to be. And those snapshots suggest something extraordinary, that the Boötes Void might be a window into the deepest rules of how structure forms in the cosmos. The early universe, shortly after the Big Bang, was almost perfectly smooth, like a freshly paved road, free of potholes or bumps. But not completely smooth. Tiny quantum fluctuations, ripples in the very fabric of spacetime, grew under the influence of gravity. Matter clumped together, forming stars, galaxies, and the web-like structure we now see. Voids are the negative space in that painting, the regions where matter didn't clump. The Boötes Void, then, might just be an extreme example of that process. Still, astronomers can't help but marvel at its emptiness. If you stood inside the Boötes Void, perched on one of its rare galaxies, the night sky above would be radically different from what we know on Earth. Instead of being sprinkled with billions of galaxies, your view would be sparse. You might see only a few faint smudges of light. The cosmic neighborhood would feel desolate, abandoned. Loneliness on a galactic scale. Some scientists have wondered aloud if such voids could hold deeper secrets. Could the Boötes Void hint at physics we don't yet understand? Could it be shaped by exotic matter, or by the mysterious force we call dark energy? After all, dark energy is the invisible hand accelerating the expansion of the universe, pulling galaxies apart. Perhaps in regions like Boötes, its effect is amplified. Others, letting their imaginations wander, have asked, could such voids be the footprints of something else? Could advanced civilizations have swept through, harvesting galaxies, leaving behind barren gaps? The speculation, of course, but speculation is often the spark that leads to discovery. The Boötes Void is big enough to let the mind roam free, asking not just scientific questions, but philosophical ones. When we gaze into the Boötes Void, we're not just staring into a lack of galaxies. We're staring into a lack of answers, a mystery defined by what isn't there. And in science, sometimes what isn't there is the most tantalizing clue of all. The deeper we look, the more we realize that emptiness is never truly empty. Space itself teems with dark matter, with invisible energy fields, with the quantum froth of particles flickering in and out of existence. The Boötes Void may look like a blank space in the universe, but in reality, it could be a laboratory for understanding the invisible scaffolding that holds the cosmos together. And so, when astronomers map the universe, they don't just chart the bright. They chart the dark. The Boötes Void reminds us that the universe is not just a story of stars and galaxies. It's also a story of silence, of absences, of the spaces between. If the Boötes Void were a painting, it would be a canvas almost entirely washed in black, with only a handful of faint brushstrokes of color. But like every canvas, its emptiness demands interpretation. What is it telling us about the universe? Astronomers began to map the Boötes Void more carefully after its discovery, using increasingly powerful telescopes. The more they charted, the more they realized just how scarce its contents were. The galaxies that do exist inside the void aren't scattered uniformly. They huddle near the edges, like hesitant swimmers refusing to dive into the deep end of the pool. The central regions of the void are almost entirely barren. That distribution raises questions. Why should galaxies cluster at the periphery while the heart remains so profoundly empty? One possibility lies in the physics of gravity and the cosmic web. Think of the universe as a giant sponge. The filaments, the strings of galaxies, are the sponge's solid framework. The voids are the holes in between. Over billions of years, gravity pulled matter into the filaments, deepening the voids as galaxies migrated outward. In this picture, the Boötes Void is not so much a hole carved out of the cosmos, but a swelling bubble that expanded as galaxies drained away. But there's another perspective, a more unsettling one. Could the Boötes Void be a statistical fluke? A rare, extreme outlier in the random scatter of cosmic structure? If so, then the void is like a natural lottery ticket, improbable but not impossible. And yet, its improbability nags at us. Because when something seems too extreme to be coincidence, science whispers, "Look closer." And looking closer reveals subtleties. The galaxies inside the Boötes Void, though few, may carry unique properties. Some appear to be unusually large, perhaps because they cannibalized smaller galaxies that wandered too close. Others show signs of isolation, evolving in splendid solitude, undisturbed by the tidal interactions that shape most galactic life. These lonely galaxies are laboratories of cosmic evolution, telling us how matter behaves when stripped of its usual neighbors. Imagine, for a moment, being a civilization in such a galaxy. For us on Earth, the night sky is a tapestry of stars and the faint glow of the Milky Way. For them, it would be stark, almost empty. Fewer galactic waypoints, fewer cosmic companions. Their mythology, their science, their philosophy might all be shaped by the overwhelming silence of their sky. The void would not just be outside them, it would live in their worldview. But the Boötes Void is not a total desert. Astronomers estimate there are perhaps 60 galaxies within it. 60 galaxies may sound like a lot, until you remember that the Milky Way's neighborhood, just a few tens of millions of light-years across, is home to thousands. This scarcity makes every galaxy inside the void precious, like rare oases in a desert. Some scientists have proposed that the Boötes Void is actually a supervoid, a combination of smaller voids stitched together. If true, then it's not a single anomaly, but a confluence of emptinesses, overlapping to form a supersized desert of space. This idea helps explain its sheer scale, but it also raises new puzzles. What mechanism allowed such a merger to happen? Did cosmic inflation stretch the early universe in uneven ways, leaving behind exaggerated hollows? Or is there a role for forces we don't yet understand? And then there's dark energy, the mysterious driver of cosmic acceleration. Could the Boötes Void be telling us something about how dark energy works? If voids expand faster than denser regions, they could grow disproportionately large over time. Studying a void like Boötes might help us test the very fabric of cosmology. The balance between matter, and dark energy. The philosophical allure of the Boötes Void is undeniable. It is a reminder that the universe is not designed for our comfort. It is not optimized for spectacle. It contains beauty and grandeur, yes, but also stretches of silence, stretches of nothingness that dwarf even our most fertile imaginations. To confront the Boötes Void is to confront the possibility that vast portions of the cosmos are simply barren, without purpose, without story, unless we give them one. This leads us to a profound reflection. Perhaps the voids, not the galaxies, are the true stage of the universe. After all, galaxies are the exceptions. Space is mostly empty. Matter is a thin frosting on a cosmic cake of nothingness. The Boötes Void simply makes this truth impossible to ignore. And yet, inside that nothingness lies the potential for everything. Emptiness is the canvas on which existence is painted. Without voids, there would be no contrast, no backdrop against which the galaxies shine. Without silence, there would be no music. Without the dark, the stars would not blaze. The Boötes Void, then, is not just a hole in space. It is a lesson, a mirror, a cosmic reminder that absence is as important as presence. That sometimes what lies inside the void is not galaxies or stars, but meaning. The meaning we choose to find in it. When we stare into the Boötes Void, we are, in a sense, staring at a scar on the universe, a wound in the otherwise intricate lattice of galaxies. And like any scar, it carries a history written in silence. One of the tools astronomers use to probe this silence is the cosmic microwave background, the afterglow of the Big Bang. This faint radiation, stretched into microwaves by billions of years of cosmic expansion, is the oldest light in the universe. By studying its subtle fluctuations, cosmologists can trace where matter gathered and where it didn't. Curiously, voids like Boötes sometimes leave imprints on this background. Faint cold spots, distortions that hint at how light journeys differently through regions of emptiness than through regions crowded with galaxies. In these distortions, scientists see clues about the unseen. Dark matter, that enigmatic substance that outweighs normal matter 5-to-1, is largely absent in voids. If the cosmic web is a skeleton, dark matter is its bone. The Boötes Void is like a missing rib, a place where that structure thins to near transparency. By studying how galaxies dance around the edges of the void, researchers can map the gravitational fingerprint of what isn't there. But emptiness doesn't mean irrelevance. Quite the opposite. Cosmologists suspect that voids are sensitive indicators of the universe's expansion. Because they are underdense, voids feel less gravitational pull inward, and so they balloon outward faster than the cosmic average. Think of them as bubbles rising in a boiling pot, swelling as the surrounding medium rushes away. The Boötes Void may thus act as a cosmic amplifier, magnifying the effects of dark energy, giving us a window into the future trajectory of the cosmos. And what a future that is. If the current acceleration continues, galaxies will retreat from one another faster and faster. Eventually, most galaxies will slip beyond our cosmic horizon, leaving each observer marooned in their own lonely island universe. In a sense, the Boötes Void offers a preview of that destiny. It shows us the solitude that awaits billions of years from now, when the lights of neighboring galaxies fade into the abyss. But let's entertain another angle, one born not from physics, but from imagination. Some thinkers have mused that enormous voids might not be natural at all. What if a sufficiently advanced civilization could manipulate cosmic matter on unimaginable scales? Could they sweep galaxies aside like gardeners clearing a field, harnessing stars as fuel, leaving behind yawning gaps? If the Kardashev scale measures civilizations by their energy use, then a void might be the footprint of a society operating at levels we cannot fathom. Of course, there's no evidence for such feats, no hidden signatures, no suspicious engineering. But the scale of the Boötes Void is so extraordinary that it tempts speculation. And speculation, while dangerous if mistaken for fact, is the seed of progress if treated as curiosity. Every scientific revolution begins with someone daring to ask, what if? Back on firmer ground, the Boötes Void also challenges our sense of probability. In simulations of cosmic structure, voids form naturally. But one as large as Boötes is rare, right on the statistical edge of expectation. Its very existence nudges us to reconsider whether our cosmological models are complete. Are we missing ingredients in the recipe of the universe? Are the constants we take for granted actually as stable as we believe? The void could be a hint, a whisper that our understanding remains incomplete. And then there is the human dimension. When we contemplate the Boötes Void, we confront our emotional response to emptiness. It unsettles us because our instincts crave fullness, pattern, connection. We seek constellations in the stars, faces in the clouds, stories in the noise. But the void resists story. It offers no handholds. It is cosmic silence, echoing louder the longer you listen. Yet in that silence lies an opportunity. The Boötes Void teaches us humility. It reminds us that the universe does not owe us spectacle or meaning. It simply is. And it challenges us to create meaning anyway, to find poetry in the absence, to let our imagination wander into the depths where galaxies should have been but are not. Perhaps, in the end, what lies inside the Boötes Void is less about physics and more about perspective. It is a mirror for the human mind, reflecting our awe, our fear, our creativity. A place where science meets philosophy, where the equations of cosmology brush against the limits of existential wonder. The Boötes Void does not exist in isolation. It is part of a grander puzzle, woven into the earliest chapters of the universe's story. To truly grasp its significance, we must journey back to the first fraction of a second after the Big Bang, to the mysterious era of cosmic inflation. Inflation was a moment of unimaginable expansion. In less than a blink, the universe grew from subatomic scales to something vastly larger than our entire observable cosmos today. This explosive growth smoothed the universe but left behind faint ripples, tiny differences in density. Those ripples were seeds. Some grew into the sprawling galaxy clusters we see today. Others marked the beginnings of the great voids. The Boötes Void may be one of the most extreme outcomes of this inflationary lottery. A region where the early ripples left almost no material to gather, no foundation for galactic cities to rise. It is a scar left not by chance alone, but by the physics of inflation itself, the universe's first act of creation, written large in emptiness. And yet, inflation may not be the full story. Some cosmologists speculate that inflation could produce not just one universe, but many, a multiverse, in which countless cosmic bubbles emerge, each with its own laws of physics. In that grander vision, the Boötes Void may be a subtle reminder that our universe is not uniformly generous with its galaxies. It may be whispering that beyond our cosmic horizon, there are other universes where voids stretch even larger, or where galaxies are packed more densely than we can imagine. But here, in our universe, the Boötes Void forces us to wrestle with scale. Its 330 million light-years are almost impossible to internalize. Even the speed of light, the ultimate cosmic speed limit, would need hundreds of millions of years to traverse it. Human lifetimes, human civilizations, even the entire span of human history are microscopic compared to such distances. When we study the Boötes Void, we are reminded of our minuteness, and yet also of our capacity to comprehend. And comprehension breeds courage, because to look into the void is to face uncertainty head-on. Some researchers propose that regions like Boötes could be natural laboratories for exotic physics. If hidden particles or forces shape the universe, their fingerprints might be most visible where normal matter is scarce. It's a paradox. The less there is, the more we might learn. The Boötes Void may also shape cosmic destiny in subtle ways. As galaxies recede with cosmic expansion, voids are expected to swell. In the distant future, they may dominate the cosmic landscape, leaving filaments thinner and galaxy clusters more isolated. In this sense, the Boötes Void is a preview of the far future, a universe in which the grand web of matter dissolves, strand by strand, into growing oceans of emptiness. And if emptiness is our future, then the void is a teacher. It tells us what survival and meaning must look like when the lights grow dim. Civilizations, if they endure, will one day live in universes where nearby galaxies are gone, where cosmic history is hidden beyond the horizon. They will look to their skies and see only themselves, much as those rare galaxies inside the Boötes Void do today. There is also an aesthetic truth here. Science is not just data, it is also art. The Boötes Void is a portrait of negative space, like the pause between notes in a symphony, like the blank margins around a painting. Without it, the universe would be less dramatic, less profound. It gives contrast to creation. It makes the galaxies sing louder because of the silence that surrounds them. In that sense, the Boötes Void is more than a curiosity. It is part of the very grammar of the cosmos. Without the void, the cosmic story would not read the same way. It would lack rhythm. It would lack breath. It would lack the reminder that sometimes what matters most is not what is present, but what is absent. In the digital age of astronomy, we no longer just observe the cosmos, we simulate it. Supercomputers now generate entire universes, evolving billions of virtual particles under the laws of physics, letting us witness in hours what would take billions of years in reality. And in those simulations, voids emerge naturally. They are not accidents, but consequences of gravity sculpting matter into its vast cosmic web. Yet, even in these artificial universes, the Boötes Void stands out. It is larger and emptier than most simulated voids, pushing the boundaries of what our models predict. That tension between observation and theory is the heartbeat of science. It is as if the void is whispering, "You are close, but not quite there." Testing those models means testing gravity itself. Einstein's general relativity has passed every trial near stars and planets. But does it still reign supreme on the largest scales? Voids like Boötes offer a proving ground. If gravity behaves differently in underdense regions, the growth of voids could diverge from our expectations. By measuring how light bends and redshifts through these cosmic deserts, we might one day confirm relativity's grip or discover cracks in its foundation. Some alternative theories of gravity predict just that: subtle deviations in void expansion, hidden clues that our universe may operate under rules stranger than Einstein imagined. In that sense, the Boötes Void is not just empty space. It is a cosmic laboratory, an experiment already running, waiting for us to read its results. But emptiness carries another role. It sets the stage for balance. Imagine the universe as a grand orchestra. The galaxies are the instruments, playing their luminous notes. The voids are the rests, the silences that give structure to the melody. Without silence, there is no rhythm. Without emptiness, there is no contrast. The Boötes Void is a silence so deep that it shapes the very symphony of the cosmos. And what of life in such a silence? It is tempting to imagine civilizations dwelling in galaxies inside the void, their view of the universe stunted by absence. Perhaps they never suspect the vast richness of the cosmic web beyond their horizon. Perhaps, in their myths, the universe is a lonely place by nature, with their galaxy as the only true island of light. Their philosophers might debate not whether they are alone in the universe, but whether there is even anything beyond their dim local sky. Such speculation forces us to reflect on our own fortune. From Earth, we see a sky rich with galaxies, a cosmic city stretching endlessly. We can trace filaments, chart clusters, and map voids. We know with certainty that the Boötes Void is an exception, not the rule. Knowledge becomes a kind of cosmic privilege, the awareness that our night sky is more generous than it could have been. And yet, perhaps the void is generous in its own way. For in its emptiness, it magnifies our curiosity. It demands questions we would not otherwise ask. What laws sculpt the cosmos into patterns of presence and absence? Why is the universe not uniform, but instead painted with extremes, clusters of unimaginable density, and voids of almost perfect nothingness? The Boötes Void may also be a lesson in humility for our future. As galaxies continue to accelerate away, future astronomers, billions of years from now, will see less and less. One day, their observable universe will resemble the Boötes Void. For them, the cosmos will appear empty, even if it once was full. Our era, then, is uniquely privileged. We live at a time when the cosmic web is visible, when the grand structure is revealed. To us, the Boötes Void is strange. To them, it will be normal. And so, the Boötes Void is both an anomaly and a prophecy. A glimpse of what lies at the edges of possibility, and a preview of what awaits us all in the deep future. When astronomers study the large-scale motions of galaxies, they sometimes notice something strange. Galaxies are not just drifting apart with the expansion of the universe. They also stream en masse toward mysterious regions. This phenomenon is called dark flow, a large-scale drift whose cause remains debated. Could voids like the Boötes Void play a role in shaping such motion? Think of it this way. A void is like a valley, and the surrounding galaxy clusters are the mountains. Matter tends to fall toward the mountains, pulled by gravity. In doing so, it drains the valley even further, making the void emptier still. The Boötes Void, colossal in its size, may act as a kind of gravitational counterweight, not by pulling, but by letting galaxies slip away from its center, flowing toward denser regions. Studying that flow could tell us about the invisible architecture of the universe. Invisible because the real sculptors of cosmic structure are often unseen. Neutrinos, for example, are particles so ghostly that trillions pass through your body every second without leaving a trace. Yet, in the early universe, their sheer abundance influenced how matter clustered. Too light to form galaxies themselves, they streamed out of dense regions, subtly puffing up voids. The Boötes Void might still carry their fingerprints, an ancient echo of the cosmic ballet between matter and ghostly neutrinos. Then there's dark matter, the silent majority of the cosmos. While galaxies gather in dense nodes of dark matter, voids are thought to be nearly devoid of it. If the Boötes Void is as empty of dark matter as it seems, it offers a rare baseline, a place to test what the universe looks like stripped almost bare of its invisible scaffolding. And in that near emptiness, physicists hope to catch glimpses of exotic physics, perhaps even new forces that only reveal themselves when space is clean of clutter. But what if the Boötes Void is more than a byproduct of physics? What if it is also a memory? In the early universe, quantum fluctuations left tiny irregularities in density. Most were small, but some were exaggerated by inflation, swelling into the enormous cavities we see today. The Boötes Void could therefore be a direct fossil from the first moments after the Big Bang, a preserved imprint of quantum chance, magnified to cosmic proportions. To peer into it is, in a way, to look into the very dice rolls that shaped reality itself. And this brings us to an even deeper thought. Perhaps the void is not just an absence, but a clue about the kind of universe we inhabit. Cosmologists speak of the anthropic principle, the idea that the universe must allow observers like us to exist, otherwise we wouldn't be here to notice it. In a cosmos dominated by voids, the odds of life emerging seem small. Yet here we are on the edge of one of the richest galaxies, looking outward into one of the emptiest places. Could the Boötes Void be a cosmic counterpoint, reminding us how fragile our place is in the balance between emptiness and abundance? The void also sharpens our sense of beauty, because beauty is not only in what we see, but in the contrasts we perceive. A flower blooming in a desert is more striking than one in a field of thousands. Likewise, the galaxies inside the Boötes Void shine with an almost poignant radiance, lonely lanterns in a sea of dark. They remind us that even in scarcity, there is wonder. Even in absence, there is presence. To explore the Boötes Void is to confront paradoxes. A place where nothingness teaches us something, where silence speaks, where emptiness is heavy with meaning. It is a hole in the universe, yes, but also a window opening onto questions that stretch beyond cosmology, into philosophy, into the very nature of being. Time behaves strangely when stretched across emptiness. Light, for example, is not simply a messenger of stars. It is also a traveler that feels the terrain of the cosmos. When photons pass through dense clusters of galaxies, gravity bends them, tugging at their paths, delaying their arrival. But when light crosses a void, it experiences the opposite, a relative acceleration, a shortcut through cosmic emptiness. The Boötes Void, then, is not merely a gap in space. It is a corridor through time. Distant quasars shining from behind it arrive with subtle signatures imprinted by the void's absence of mass. By decoding those imprints, astronomers can refine their understanding of cosmic expansion. In this way, even nothingness becomes a measuring stick for the universe's deepest rhythms. And those rhythms matter because time itself is shaped by the large-scale distribution of matter. The great cosmic web evolves unevenly. Dense regions collapse faster, birthing clusters, while voids expand faster, thinning into vast deserts. The Boötes Void reveals how the fabric of time and space stretches differently depending on where you are. In a galaxy cluster, the future is crowded and turbulent. In the Boötes Void, the future is silence, expanding quietly in every direction. Now imagine being a quasar, a blazing black hole engine at the dawn of time, sending your light through the Boötes Void. For billions of years, that light would cross a darkness almost untouched by galaxies. By the time it reaches us, it carries not only the story of its source, but also the quiet testimony of the void it crossed. Astronomers call this the integrated Sachs-Wolf effect, subtle fingerprints on photons that whisper of dark energy and cosmic emptiness. The Boötes Void is thus not just an absence, but an active participant in the storytelling of the universe. But the void's role does not end with today's observations. It may also be a preview of tomorrow. As expansion accelerates, galaxies are carried away from one another, and the universe slowly loses its fire. Stars burn out, black holes evaporate. In trillions of years, the grand cosmic web will unravel, leaving behind only scattered islands in a boundless sea. When that day comes, every galaxy will know what it means to live inside a Boötes Void. This destiny reframes our perspective. What we call extraordinary today will one day be universal. The Boötes Void is not a glitch. It is a prophecy, foreshadowing the loneliness of the far future. Perhaps billions of years from now, future astronomers will look outward and see nothing but their own stars fading into dark. And perhaps they will wonder if the cosmos was ever richer, if the universe once sang with light and connection. For us, the Boötes Void is a curiosity. For them, it will be a mirror. And yet, emptiness does not negate significance. If anything, it sharpens it. The galaxies that remain inside the Boötes Void are testaments to resilience. They shine not because they are numerous, but because they persist against all odds, like campfires burning in a wilderness of night. They remind us that even in the deepest silence, creation endures. The Boötes Void teaches us that time and emptiness are partners. Together, they sculpt the destiny of the cosmos. And by gazing into that emptiness, we confront not just the physics of the universe, but the poetry of its unfolding. The void is not the end of the story. It is a chapter still being written, one in which absence carries as much weight as presence, and silence speaks louder than sound. When cosmologists map the oldest light in the universe, the cosmic microwave background, or CMB, they find not perfection but texture. Tiny variations in temperature, mere millionths of a degree, chart the seeds of structure that would later become galaxies, clusters, and voids. And among those fluctuations are curious cold spots, regions slightly cooler than their surroundings, where photons seem to have lost energy on their billion-year journey. Voids like the Boötes Void may be responsible for some of those cold spots. As light passes through an underdense region, the lack of gravitational pull alters its energy. Photons enter the void one way and exit another, leaving subtle fingerprints on the CMB. Studying these imprints is like eavesdropping on the dialogue between light and emptiness, a dialogue that stretches back to the dawn of time. But the void is more than a silent participant in cosmic conversation. It is also an engine of entropy, the measure of disorder in the universe. In dense regions, matter clumps, collapses, forms stars and black holes. Complexity flourishes, but entropy climbs quickly. In voids, by contrast, there is little to collapse. Their very emptiness slows the march of disorder. If clusters are furnaces of chaos, voids are reservoirs of calm. The Boötes Void may thus be one of the quietest places in the cosmos, a sanctuary where the arrow of time ticks differently, its increments stretch thin by the absence of activity. This duality, chaos in clusters, serenity in voids, hints at something deeper. Perhaps the universe requires both to balance its story. Just as silence gives meaning to sound, so emptiness gives context to creation. Without voids, the brilliance of galaxies would have no backdrop. Without stillness, motion would lose its drama. The Boötes Void is the universe taking a breath between chords, preparing the next note in its grand symphony. And yet, its scale tempts even bolder speculation. Some physicists suggest that the universe itself may be a kind of hologram, a three-dimensional reality projected from information encoded on a distant boundary. If so, then voids like Boötes might be more than accidents of gravity. They could be patterns in the projection, subtle gaps in the cosmic code. Just as pixels sometimes reveal the limits of a screen, perhaps the vast emptiness of the Boötes Void is whispering about the limits of the simulation we inhabit. Of course, such ideas remain speculative. But speculation has always been part of exploration. Every great discovery begins with daring to imagine what lies beyond the known. And the Boötes Void, in its stubborn emptiness, demands imagination. It invites us to consider possibilities as vast as the void itself. Multiverses, hidden dimensions, simulations, concepts that stretch science into philosophy and philosophy back into science. What lies inside the Boötes Void? Perhaps the truest answer is this: possibility. The possibility that emptiness is not a dead end, but an opening, a frontier, a reminder that the cosmos is not finished revealing itself, and that sometimes the most profound discoveries are hidden in the places where there seems to be nothing at all. The Boötes Void is often described as a hole in the distribution of galaxies, but it may also be a clue to something even grander: the shape of the universe itself. Cosmologists debate whether the cosmos is infinite or finite, whether it bends back on itself like the surface of a sphere or stretches endlessly like an unbroken plane. Voids, in their scale and geometry, may carry hints about this cosmic topology. If the universe were a vast three-dimensional tapestry, voids would be the spaces where the weave thins. The Boötes Void, enormous and striking, may be an accent in that design, a pattern that could help reveal whether our cosmos is curved, flat, or something stranger still. By studying the alignment and distribution of such voids, scientists attempt to glimpse the blueprint of the entire universe. And yet, the void is not only about geometry, it is also about time. In a way, voids act as natural clocks. Because they expand faster than denser regions, their growth reflects the pace of cosmic acceleration. Measure how quickly a void swells, and you measure the heartbeat of the universe. The Boötes Void, with its extraordinary scale, is a timepiece ticking in silence, recording the expansion of space itself. Light traveling through such emptiness experiences something profound. With so little matter to scatter or distort it, photons cross voids almost unaltered, like runners in an open field. But because the void is stretching as they travel, those photons also carry a record of cosmic acceleration, their wavelengths lengthened by the emptiness they traverse. In this sense, the Boötes Void acts as a cosmic lens, not by bending light, but by stretching it, encoding information about the universe's future in the faint glow of distant galaxies and quasars. And if the void is a lens, then what it reveals is more than physics. It reveals a philosophy of existence. For billions of years, galaxies have drifted outward, structures have formed, stars have ignited and died. Yet, amid all this activity, vast regions like the Boötes Void remain almost untouched, suspended in stillness. They remind us that creation is uneven, that the universe does not distribute its wonders evenly across the sky. Some regions are fertile, others are barren. Some are bustling cities of galaxies, others are deserts of silence. This unevenness raises a profound question. What does it mean for consciousness? If intelligent life exists inside a galaxy deep within the Boötes Void, their perception of reality would be vastly different from ours. With so few neighboring galaxies, they might never guess the universe's true richness. Their cosmic story would be one of solitude, their philosophy shaped by absence. To them, the void would not be a feature, it would be the universe. For us, standing at the edge of such emptiness, the Boötes Void becomes a mirror. It reflects our fortune in living in a galaxy surrounded by countless others. It reminds us that knowledge is not evenly distributed, and that perspective is a kind of cosmic lottery. Our sky, full of galaxies, gives us a truth that others may never glimpse. And yet, the void is not cruel. It does not hide galaxies out of malice. It simply is. It is the universe in one of its purest forms. Absence stretched across unimaginable distances. A reminder that not all space is filled, not all canvases are painted, not all symphonies play without pause. So when we ask, what lies inside the Boötes Void? The answer may be simple: a story. A story of geometry, of time, of perspective. A story written in the language of silence, waiting for us to learn how to read it. When we think of the Boötes Void, we imagine silence, an emptiness unbroken by the usual chorus of galaxies. Yet, silence is not the same as stillness. Even in nothingness, the universe vibrates, and some of those vibrations reach us from the very first heartbeat of creation. Primordial gravitational waves, ripples in spacetime unleashed during the earliest fractions of a second after the Big Bang, may still pass through regions like the Boötes Void. Unlike light, which is scattered and absorbed by matter, gravitational waves flow almost undisturbed through emptiness. If we could tune our instruments finely enough, voids could become listening posts for the faint music of the universe's birth, amplifying signals otherwise drowned out by the noise of galaxies and clusters. But the void's role in testing physics goes beyond echoes of the past. Some theories propose that our universe might have more than 3 dimensions of space. If hidden dimensions exist, their effects could be subtle, altering how gravity behaves at cosmic scales. The Boötes Void, nearly stripped of matter, is like a pristine stage where those deviations might appear most clearly. In its stillness, we might glimpse shadows of unseen dimensions, the fingerprints of a deeper reality just beyond our perception. And then there is the question of destiny. Matter and energy flow according to the large-scale geometry of the cosmos, and voids are central to that flow. They are not empty accidents, they are drivers of structure, pushing galaxies into filaments, shaping the web itself. Without voids, the universe would not look as it does. Its architecture would collapse into uniformity. The Boötes Void, massive and profound, is one of the universe's great sculptors, shaping the stage upon which galaxies evolve. In its vastness, we also see a preview of the ultimate fate of matter. Stars within galaxies inside the Boötes Void will one day exhaust their fuel, collapsing into remnants. White dwarfs, neutron stars, black holes. With few neighboring galaxies to merge with, these lonely systems will age in isolation, their lights fading into the abyss. Over unimaginable timescales, even their black holes will evaporate into nothing. The void will outlast them all, patient, unhurried, eternal. For us, though, the Boötes Void is not just a cosmic curiosity, it is a meditation. It reminds us that reality is not always crowded, not always lively. It teaches that absence, too, has weight, that silence, too, can be full of meaning. The universe speaks not only in the language of stars, but also in the language of emptiness. So what lies inside the Boötes Void? Perhaps the truest answer is potential. The potential to listen to primordial waves, to test new dimensions, to glimpse the long future of matter. It is not simply nothing. It is an arena where the deepest questions of physics and philosophy converge. A space where the universe reveals itself not in abundance, but in restraint. Astronomers once believed the universe was uniform on the largest scales, the same in every direction, the same wherever you looked. This principle of cosmic isotropy has been a guiding assumption for decades. But voids like the Boötes Void challenge us to look closer. If the universe is truly even-handed, then why does such an enormous desert exist? Large-scale surveys have revealed puzzling alignments in the cosmos. Galaxies oriented along vast filaments, clusters stretched into walls spanning hundreds of millions of light-years. Some even suggest a preferred direction, an axis of sorts, across which cosmic structures seem oddly correlated. Could the Boötes Void be part of this pattern? A missing piece in a grander alignment that defies the expectation of randomness? If so, the void is more than an absence. It is a coordinate in a cosmic map we have yet to decode. Perhaps it reveals that the universe has texture at scales we did not expect, that its smoothness is only an illusion when viewed from too far away. Philosophically, this forces us to reconsider what we mean by nothing. When we call the Boötes Void empty, we really mean empty of galaxies. But is it truly nothing? Hardly. Even the darkest reaches of the void hum with activity. Virtual particles flicker in and out of existence. Quantum fields ripple invisibly. Dark energy fills every cubic centimeter. Gravity itself permeates the void, curving space ever so slightly. The Boötes Void may lack galaxies, but it is not a vacuum devoid of reality. This distinction between nothing and something is crucial. To the human mind, nothingness is unsettling, a concept of absence. But physics tells us that even the most barren void is alive with unseen players. To look at the Boötes Void is to see an arena where the hidden forces of the universe dominate. Where matter is absent, the invisible rules of reality shine through. And then there is the question of perspective. From Earth, the Boötes Void appears extraordinary. But perhaps, to a civilization living within it, it is the baseline of existence. Their night sky would be sparse, their cosmic horizon subdued. They might not even know galaxies come in greater abundance elsewhere. For them, the void would not be strange, it would be normal. And our star-filled heavens, if they could glimpse them, would seem the anomaly. That contrast reveals something profound. The universe is not one story, but many. Its meaning depends on where you stand, on what you can see. For us, the Boötes Void is a puzzle. For others, it might be home. So what lies inside the Boötes Void? Not a barren nothingness, but a challenge. A challenge to our assumptions of uniformity. A challenge to our definitions of emptiness. A challenge to our imagination to see beyond galaxies, to listen for the whispers of the invisible, to recognize that even the darkest stretches of the universe are not truly void, but full of mystery waiting to be understood. When we imagine the universe, we often picture galaxies, stars, and planets. But woven through this cosmic fabric is something far more subtle: magnetism. Invisible magnetic fields stretch between galaxies, threading the intergalactic medium. They influence how particles move, how gas collapses, how cosmic rays navigate the universe. Inside a colossal emptiness like the Boötes Void, magnetism takes on a different character. With so few galaxies to generate strong magnetic fields, the void may be among the quietest magnetic regions in the cosmos. This magnetic silence allows astronomers to search for the faintest signatures of primordial fields, relics left over from the Big Bang itself. If we can measure those whispers, we might learn whether magnetism was written into the universe from the very beginning, or whether it emerged later, seeded by galaxies and stars. The Boötes Void is also a stage for one of the most enigmatic phenomena in astrophysics: ultra-high-energy cosmic rays. These are particles, protons or nuclei, accelerated to energies millions of times greater than anything humans can achieve in our most powerful accelerators. Their origins remain uncertain. Some are thought to come from quasars or gamma-ray bursts, but their paths are twisted by magnetic fields, making it difficult to trace them back to their source. Here is where the void becomes valuable. In a region so empty, so free of tangled fields, cosmic rays may travel in straighter lines. If we catch them emerging from the Boötes Void, their trajectories could act like arrows pointing toward their birthplaces. The emptiness of the void may thus become a natural laboratory for tracking the universe's most extreme particles. And then there is the question of travel, not for particles but for civilizations. In the distant future, as technology evolves, intergalactic journeys may one day be conceivable. Yet the Boötes Void stands as a barrier unlike any other. To cross it would be to embark on a voyage lasting hundreds of millions of years, even at relativistic speeds. It is the cosmic equivalent of an ocean without islands, a desert without oases. For future explorers, the void will be both a challenge and a reminder of the scale of their ambition. But perhaps the greater truth is this: the Boötes Void shows us that the cosmos is not equally accessible everywhere. It reveals natural boundaries, imposed not by walls, but by distance and absence. It teaches that while the universe is connected, it is also divided into webs of light and oceans of dark, into clusters of matter and caverns of emptiness. For humanity, recognizing those boundaries is an act of humility. We may dream of traversing the stars, of spanning galaxies, of building civilizations beyond our world. Yet the Boötes Void reminds us that there are limits, horizons set not by imagination but by physics. And still, within those limits, meaning flourishes. The very act of seeing the void, of naming it, of asking what lies inside, is an act of defiance against silence. So what lies inside the Boötes Void? Weak magnetic whispers, straightened paths of cosmic rays, barriers to travel that are as inspiring as they are daunting. It is a reminder that even emptiness has structure, and that even silence can teach us how to listen. At first glance, the Boötes Void appears to be a pristine vacuum, stripped of galaxies, stripped of meaning. But science is cautious about declaring anything truly empty. With every advance in technology, what once looked barren is revealed to be richer than we imagined. Astronomers now suspect that voids may not be entirely devoid of matter. Instead, they could hide diffuse gas, thin clouds stretched so tenuously that they glow only faintly, invisible to ordinary telescopes. This gas may be the missing link in the cosmic census, accounting for the lost baryons, normal matter that should exist according to theory, but has been notoriously difficult to detect. The Boötes Void may thus conceal vast reservoirs of hidden substance, not luminous like galaxies, but crucial to balancing the books of cosmology. And perhaps there is more. Some theories predict the existence of dark photons, hypothetical cousins of ordinary photons, capable of mediating interactions within the dark sector of the universe. If such particles exist, voids would be the ideal place to look for them. In regions where ordinary matter is scarce, the signals of exotic physics could stand out more clearly. The Boötes Void, in its vast emptiness, may act as a stage where these hidden actors perform their quiet play, unnoticed in busier parts of the universe. There is also the question of faint galaxies, dwarf systems so dim and diffuse that they escape most surveys. Advanced instruments, like those on the James Webb Space Telescope, may one day uncover such elusive galaxies sprinkled through the Boötes Void. They would not transform the void into a crowded place, but they would remind us that even in the darkest deserts, there are hardy survivors, flickers of light clinging to existence. These faint galaxies, if they exist, embody resilience. They evolve in isolation, far from the gravitational drama of clusters, free from mergers and tidal disruptions. Their stars may live longer, their histories less chaotic. To study them would be to glimpse an alternative path of galactic life, a quieter, slower rhythm set against the silence of the void. In this way, the Boötes Void teaches us about endurance. It shows that scarcity does not mean absence, and isolation does not mean irrelevance. Even in the most extreme conditions, the universe finds ways to persist. And for us, there is symbolism here. Humanity, too, often feels small, fragile, alone in the cosmic expanse. Yet the faint galaxies of the Boötes Void remind us that survival is possible, even in the harshest emptiness. That meaning can endure, not because the environment is generous, but because persistence itself creates significance. So what lies inside the Boötes Void? Not just absence, but hidden gas, possible exotic particles, and perhaps galaxies too faint to see. It is a space that whispers resilience, the cosmos reminding us that even in its darkest stretches, the story of existence continues. When astronomers map the universe on the largest scales, they find filaments of galaxies flowing like rivers across a dark sea. These filaments thread around voids, outlining their boundaries, shaped by the gravitational push and pull of mass. In this architecture, voids are not passive gaps but active players. They push, they stretch, they help sculpt the grand geometry of everything we see. The Boötes Void, with its extraordinary size, is a gravitational counterweight in this cosmic dance. Its emptiness exerts pressure on surrounding filaments, subtly influencing the direction of galactic streams. Over billions of years, it has nudged matter away from its core, sharpening the contrast between itself and the luminous walls that border it. In this sense, the void is like an invisible hand guiding the flow of galaxies, an unseen conductor shaping the symphony of cosmic structure. Some theorists suggest that enormous voids may act like gravitational echo chambers. As matter drains outward, small fluctuations inside the void can amplify, bouncing and resonating through the sparse medium. These ripples may carry information about the earliest seeds of structure, preserved more cleanly than in crowded regions. If so, the Boötes Void may hold echoes of the very first instabilities of the cosmos, faint reminders of the quantum fluctuations that launched everything. But the meaning of the void is not confined to physics alone. It also deepens our encounter with solitude. Human beings are social creatures. We seek connections, patterns, constellations. To contemplate the Boötes Void is to imagine existence stripped of connection. A galaxy adrift in a darkness where neighbors are few and far between. What would loneliness mean on such a scale? What philosophies would emerge from skies that speak so little? Perhaps civilizations inside the Boötes Void would grow inward rather than outward, focusing not on mapping the cosmos but on cultivating meaning in isolation. Their myths might not speak of crowded heavens but of eternal silence, of creation born not in abundance but in scarcity. For them, emptiness would not be an exception, it would be the rule. For us, gazing in from outside, the void is a mirror of our own fears and aspirations. It reflects the human confrontation with nothingness, not just in space but in life. We fear the void of meaning, the absence of purpose. And yet, just as galaxies survive within the Boötes Void, so too can purpose emerge even in silence. The void is not an erasure of meaning, but a canvas demanding that meaning be painted upon it. So what lies inside the Boötes Void? A gravitational force shaping the universe, a quiet chamber echoing with ancient ripples, and a profound metaphor for solitude, one that challenges us to find significance, not in abundance, but in the courage to persist within emptiness. The story of the Boötes Void is inseparable from the story of cosmic acceleration. For most of the universe's history, gravity reigned supreme, pulling matter together, slowing the expansion. But a few billion years ago, something shifted. A mysterious pressure, what we call dark energy, began to dominate, stretching space at an ever-increasing rate. Voids are where this dominance is most clearly revealed. In dense regions, gravity fights dark energy, binding galaxies into clusters. In underdense regions, there is no such resistance. Expansion runs almost unchecked, like wind rushing through a canyon. The Boötes Void, vast and unopposed, may be one of the clearest demonstrations of dark energy's quiet power. Its size is not only a result of what it lacks, but of what pushes it outward. If acceleration continues, voids will one day define the very geometry of the observable universe. Galaxies, once linked in a great cosmic web, will retreat farther apart, while voids expand and merge. What is today an extreme exception, a desert in the middle of a crowded sky, may become the rule. The Boötes Void is not just a snapshot of the present. It is a preview of the universe to come. And yet, its existence also sharpens the urgency of our search for understanding. If voids grow ever larger, one day there will be little left to study. Future astronomers may find themselves imprisoned in their local galaxies, blind to the structures that once defined the cosmos. They will not know of the cosmic web. They will not know of the Boötes Void. For them, the universe will appear small and solitary. Only we, in this fleeting moment, can see the universe as it truly is, rich with galaxies, yet punctuated by profound emptiness. Philosophically, the void reflects our own quest for meaning. Humanity has always sought purpose in the stars, in myths, in religion, in science. But the Boötes Void reminds us that the universe is not obligated to provide meaning in abundance. It offers instead a challenge, to look into emptiness and find purpose ourselves, to recognize that absence can be as instructive as presence, that silence can be as eloquent as sound. So what lies inside the Boötes Void? The fingerprint of dark energy, the future shape of the cosmos, and the deepest challenge to human imagination. It is both a scientific puzzle and a philosophical mirror. And in contemplating it, we are reminded that our journey is not only about what the universe contains, but about how we choose to interpret what it withholds. The Boötes Void is not merely an oddity in the cosmic web. It may be a fossil of ancient transformations in the universe itself. Cosmologists speak of phase transitions, moments when the cosmos changed its state, much like water freezing into ice or steam condensing into liquid. In the first fractions of a second after the Big Bang, the universe may have shifted through several such transitions, cooling from unimaginable energies into the familiar forces of physics we know today. What if voids are the fingerprints of those transitions? Regions where fields settled differently, leaving behind scars in the cosmic distribution of matter. The Boötes Void could be a frozen memory of an early instability, magnified by billions of years of expansion into the yawning cavity we see now. To study it is to study the universe's adolescence, a record of how raw potential became physical law. Among the candidates for such transformations are quintessence fields, hypothetical, dynamic forms of dark energy that evolve over time. If quintessence exists, its effects would be most visible in places where matter is sparse. Voids, with their vast stretches of near-nothingness, would act as test sites for its influence. The Boötes Void, in particular, might carry subtle signatures of a cosmic energy that shifts as the universe ages, a whisper that dark energy is not a static force but a living, changing field. And then comes the bolder possibility that voids like Boötes are not simply passive gaps but laboratories of reality. In their silence, stripped of clutter, the underlying structure of spacetime itself may be easier to read. Could we test whether the universe is truly continuous, or whether space is granular, pixelated at the smallest scales? Could voids expose the quantum threads from which the fabric of reality is woven? In this view, the Boötes Void is not absence but revelation. By removing distractions, it reveals what is most fundamental. Like a minimalist painting, it strips away the unnecessary, leaving only the essential. The void invites us to look not at what is there, but at the stage itself, the canvas upon which galaxies are drawn, the invisible laws that make existence possible. For humanity, this is as much a philosophical invitation as a scientific one. We are asked to confront the possibility that nothingness is not empty but pregnant with possibility. That silence is not the end of music but its foundation. That voids are not errors in the cosmic story but vital chapters, reminding us that absence, too, has meaning. So what lies inside the Boötes Void? Perhaps the echoes of ancient phase transitions, the fingerprints of evolving dark energy, and the raw canvas of reality itself. It is a place where the universe is stripped bare, where the fundamental whispers louder than the familiar. A place that dares us to imagine not just what is missing, but what deeper truths are waiting to be found. In science, sometimes the most revealing places are not those that teem with activity, but those that seem quietest. Voids, paradoxically, are amplifiers. Their emptiness strips away noise, leaving faint signals exposed. The Boötes Void, with its colossal silence, is one of the universe's greatest amplifiers. For example, cosmic background radiation, the faint afterglow of the Big Bang, passes differently through voids than through clusters. In dense regions, photons scatter, their paths twisted by hot gas and tangled gravity. But in the Boötes Void, the path is clean. Any slight anomaly in that radiation stands out more clearly, like a whisper heard in a silent room. By listening to such whispers, astronomers can test the deepest models of cosmology. This amplifying role extends to exotic ideas as well. The holographic principle, a theory suggesting that our three-dimensional universe may be encoded on a distant two-dimensional boundary, predicts subtle imprints on the fabric of spacetime. We're better to search for such delicate signatures than in the emptiest canvases the cosmos provides. The Boötes Void may be less a gap in matter and more a magnifying glass, focusing our view on the underlying rules of reality. Voids may also hold clues to the quantum nature of spacetime. If space is not infinitely smooth but instead granular, composed of tiny, indivisible units, those grains might reveal themselves most clearly across vast, empty expanses. Like light passing through a crystal, photons crossing the Boötes Void could carry interference patterns that betray the pixelated texture of the universe. Detecting such effects would revolutionize physics, connecting quantum mechanics to cosmology in a single breathtaking leap. But beyond the scientific, the Boötes Void carries a deeper lesson. It teaches us that emptiness itself is not a void of meaning. In human life, silence is often uncomfortable. We fill it with words, with motion, with distraction. Yet in silence lies reflection. In stillness lies clarity. The Boötes Void is the universe's meditation chamber, a place where the usual noise of galaxies is hushed and the deeper structure of existence comes forward. Imagine standing within one of its rare galaxies, looking into skies devoid of neighbors. You might feel abandoned by the cosmos, or you might feel chosen, standing at the edge of creation's rawest truth, where absence itself becomes the message. The void would not tell you what to think, but it would demand that you think. So what lies inside the Boötes Void? Amplification, clarity, a cosmic stage where the faintest truths of existence may be revealed, not in abundance but in restraint. It is an emptiness that is not empty at all, but full of lessons waiting to be heard. The cosmos often surprises us with its symmetry. Galaxies spin in graceful balance, clusters form like beads on invisible strings, and the cosmic microwave background stretches nearly evenly across the sky. But symmetry is never perfect, and it is in the imperfections that truth hides. The Boötes Void is one such imperfection, a staggering reminder that the universe is not evenly painted. If the cosmos were truly uniform, we would expect no region so barren, no gap so immense. Yet the Boötes Void stretches across hundreds of millions of light-years, daring us to question whether symmetry is only an approximation. Could the universe itself have a hidden preference, a subtle directionality, a cosmic north and south, hinted at by these outsized voids? Some researchers have explored whether the distribution of voids and clusters points to a cosmic axis, a large-scale alignment across billions of light-years. If such an axis exists, it would overturn one of the bedrock assumptions of cosmology, that no place is special, no direction preferred. The Boötes Void, with its overwhelming emptiness, may be part of this greater puzzle, a gap not of randomness but of pattern. And yet, whether random or purposeful, the void reshapes our imagination. To us on Earth, the universe is crowded and luminous. Our night sky tells a story of connection. Stars woven into constellations, galaxies sparkling at the edge of vision. But the Boötes Void offers a different story, one where absence dominates, where solitude is the rule. It reminds us that the universe is not written in a single narrative. It is a library, each region a different book, some rich with characters, others spare and silent. For civilizations that might inhabit galaxies within the Boötes Void, their cosmic mythology would differ profoundly from ours. They might see their isolation not as anomaly but as destiny. They would interpret the sky as confirmation that existence is solitary, that the universe speaks in whispers, not choruses. Where we find meaning in abundance, they would find meaning in scarcity. This reflection circles back to us. The Boötes Void is not just a scientific mystery. It is a philosophical mirror. It asks us to consider how our own sense of purpose is shaped by environment. If our sky were emptier, would we be less curious? Or would the loneliness drive us harder to seek connection? The void does not answer. It only poses the question, letting us wrestle with the silence. So what lies inside the Boötes Void? Perhaps a challenge to symmetry, perhaps a hint of cosmic direction, and certainly a canvas upon which human imagination paints its boldest contrasts. It is a silence that speaks not of nothingness, but of perspective, reminding us that the universe is vast enough to contain many truths, depending on where you stand. Every observer in the universe, no matter where they stand, is surrounded by a cosmic horizon. It is the ultimate boundary of sight, the limit beyond which light has not yet had time to reach them since the dawn of the cosmos. For us, This horizon sits about 46 billion light-years away. Beyond it, the universe may continue endlessly, but we cannot know. Voids like the Boötes Void echo this concept on a smaller stage. They are horizons of a different kind, not boundaries of time, but boundaries of matter. From within one of its rare galaxies, the nearest luminous neighbors may lie so far away that they blur into invisibility. The result is a personal horizon of knowledge, a limit to what an observer inside the void could ever discover about the richness of the cosmos. In this way, the Boötes Void is a foreshadowing of what awaits all civilizations. As dark energy continues its relentless push, galaxies will one day slip beyond our horizon. The universe will grow lonelier, until each galactic island is surrounded by a void far larger than Boötes. What feels exceptional now will become universal. The horizon will shrink inward, knowledge itself collapsing under the weight of cosmic expansion. And so the Boötes Void becomes a kind of time machine, not because it takes us backward, but because it shows us forward. It is a glimpse of the universe's destiny, when emptiness is no longer an anomaly but the default. In that future, science will be harder, history will be hidden, and truth itself will be narrower. Only now, in this brief window of cosmic time, can we see the great web in its entirety. But the Boötes Void is more than a physical horizon. It is also a metaphorical one. It reminds us of the boundaries of human knowledge. We can measure galaxies, map cosmic filaments, calculate expansion. Yet when we stare into such vast emptiness, we confront questions our equations cannot yet answer. Why here? Why so large? Why does the universe allow such imbalance? The void stretches not just across space, but across the gap between what we know and what we long to understand. And in that gap lies the essence of discovery. Science is not the conquest of certainty, but the humility of asking better questions. The Boötes Void does not diminish our curiosity. It sharpens it, reminding us that every horizon is temporary, every limit a prompt to reach further. So what lies inside the Boötes Void? A horizon both cosmic and human. It is the edge of visibility, the boundary of comprehension, the reminder that the universe is always larger than our understanding. And perhaps that is the greatest truth of all, that knowledge is not about reaching an end, but about learning to navigate the endless horizons that await us. When we speak of the universe's first light, we often mean the cosmic microwave background, the afterglow released 380,000 years after the Big Bang, when the cosmos cooled enough for atoms to form. But there was another light before that. A brief, intense flash of radiation created in the primordial plasma, long before stars and galaxies existed. Most of that light has been scattered, absorbed, and reprocessed over billions of years. Yet in places like the Boötes Void, where matter is scarce, faint traces of this ancient illumination may still survive. The void, in its stillness, may preserve these relics more faithfully than crowded regions. Without dense gas to scatter photons, without galaxies to distort their paths, the Boötes Void acts like a pristine chamber, allowing the earliest whispers of light to pass through almost untouched. Studying it may give us a window not just into the first light, but into the prehistory of light, a record of conditions when the universe was still opaque. This idea stretches further. Some theories suggest that the universe may not have begun with the Big Bang alone, but with a pre-Big Bang phase, a contracting cosmos that rebounded, or a quantum fluctuation from a deeper reality. If so, voids might be the places where such primordial fingerprints are most detectable. The Boötes Void could be more than an absence of galaxies. It could be a portal to earlier epochs, carrying subtle anomalies imprinted before our universe even truly began. It's a radical possibility that emptiness holds more history than fullness. Clusters tell us how matter grew, but voids may tell us why it grew at all, why structure emerged from smoothness, why something came out of near-nothing. The Boötes Void, in its enormity, may therefore be the most honest storyteller of the cosmos, not decorating the sky with spectacle, but whispering the origins that spectacle rests upon. And in contemplating this, we rediscover our role as humans. We are not just catalogers of galaxies or calculators of distances. We are storytellers of the cosmos. The Boötes Void reminds us that stories do not come only from what is present, but also from what is absent, from silence as much as from sound, from questions as much as from answers. For the galaxies inside the Boötes Void, there may never be such a story. Their skies are too empty, their horizons too narrow. But from our vantage point, rich with data and imagination, we can give the void a voice. We can translate its silence into narrative, its absence into meaning. So what lies inside the Boötes Void? Perhaps the memory of the universe's earliest light. Perhaps the fingerprints of times before time. And certainly, the challenge to humanity to weave emptiness into the fabric of our cosmic story, to take what is silent and make it speak. The Boötes Void is often described as empty of galaxies, but it is not empty of influence. Beneath the surface of visible matter lies the hidden architecture of dark matter, shaping everything we see yet never revealing itself directly. If the cosmic web is a great scaffold, dark matter is its steel frame, unseen but essential. Voids like Boötes are where that frame thins almost to transparency. By mapping how galaxies move around the edges of the void, astronomers can infer where dark matter hides, or where it fails to appear. And here lies the puzzle. Does the Boötes Void contain strands of invisible mass we cannot yet detect? Or is it truly stripped bare? If it is the latter, then the void is not just a gap in galaxies, but a gap in the very skeleton of the cosmos. Such gaps may alter the geometry of the universe itself. The distribution of voids and filaments together determines whether space is curved like a sphere, saddle-shaped, or flat as a sheet. The Boötes Void, with its extreme proportions, may be a decisive piece of this puzzle. By studying it, cosmologists refine their maps of curvature, and by extension, their estimates of the universe's fate. If space is flat, expansion may continue forever. If curved, collapse could one day return everything to fire. The void, in silence, may hold the answer to eternity. But the Boötes Void is not only a cosmic laboratory. It is also a meditation on fragility and endurance. Galaxies inside it live isolated lives. Cut off from frequent interactions, they evolve slowly, almost cautiously. They are fragile in their solitude, yet enduring because of it. Where crowded galaxies burn bright in collisions and mergers, void galaxies survive like lone trees in a desert, growing quietly against the odds. For humanity, this duality speaks to our own condition. We are fragile, a single species on a single planet, orbiting a star in one corner of a galaxy. Yet we endure, precisely because we persist in seeking meaning against the backdrop of an indifferent universe. The Boötes Void mirrors this truth, that survival is not guaranteed, but significance emerges from persistence. So what lies inside the Boötes Void? The thinning frame of dark matter, the geometry of the cosmos itself, and the parable of fragility turned into endurance. It is emptiness, yes, but emptiness that sculpts, emptiness that teaches, emptiness that endures. The large-scale universe is not static. Gas flows between galaxies, trickling along filaments, feeding star formation. Like rivers on Earth, these cosmic streams connect environments, moving material from one region to another. But in a place like the Boötes Void, those rivers dry up. With so few galaxies to attract and capture intergalactic gas, the flow thins into almost nothing. The result is a region where creation slows, where new stars are born far less frequently, and where galaxies must survive largely on the reserves they already hold. In this way, voids are natural laboratories for understanding the balance of cosmic nourishment. Where clusters are bustling markets of exchange, trading gas, stars, and dark matter, voids are the wilderness. Studying them reveals what happens when galaxies are left to fend for themselves, cut off from the supply chains of the cosmos. And yet, the Boötes Void is likely not a singular cavity but part of a larger, connected structure, a supervoid. These are vast regions where several smaller voids overlap, merging into one enormous expanse. If this is true, then the Boötes Void is not an isolated anomaly but a node in a much greater emptiness. Supervoids may span billions of light-years, reshaping the flow of galaxies on scales so vast they challenge our ability to visualize them. Supervoids have even been linked to puzzling features in the cosmic microwave background, such as unusually cold regions. Could the Boötes Void be partly responsible for one of these anomalies, bending light and subtly cooling the ancient glow of the Big Bang? If so, then its influence stretches not just across space but across time, touching the very relic radiation that defines our cosmic origin. On a more philosophical level, the Boötes Void speaks to the tension between isolation and connection. The universe is built on webs of relation, galaxies linked by filaments, stars bound in orbits, atoms tied by forces. But in the void, those ties are fewer, stretched thin. It is the cosmic equivalent of standing alone in a desert, with horizons empty in every direction. And yet, even in isolation, galaxies persist. Even in silence, there is structure. The Boötes Void reminds us that existence does not depend solely on connection. It also depends on resilience, that life and meaning can endure even where the bonds are weakest. So what lies inside the Boötes Void? Starvation of intergalactic gas, the merging of smaller voids into a supervoid, and a profound lesson about the balance between isolation and connection, a balance that defines not only the cosmos but the human condition. In the cosmic wilderness, even the faintest players leave their mark. Among them are neutrinos, ghost-like particles that stream through the universe in unimaginable numbers. They rarely interact, slipping effortlessly through planets, stars, and galaxies. And yet, in the early universe, their restless motion shaped the growth of cosmic structure. Voids like the Boötes Void may still carry the memory of that influence. Because neutrinos are so light, they tend to escape dense regions, pooling instead in the emptier ones. Over billions of years, this subtle migration may have swelled the void, puffing it larger than gravity alone would predict. If we can measure the void's true profile, we may glimpse the fingerprints of neutrinos on the cosmic stage, learning about particles that remain nearly invisible in every other way. But the Boötes Void is not just about the past. It also hints at the future of cosmic flows. Gas, matter, and galaxies move along filaments toward massive clusters. In doing so, they leave behind even emptier regions. Over time, the Boötes Void will not shrink but grow, as more material drains away from its center. It is a dynamic cavity, expanding not because of what it contains, but because of what it continually loses. In the far future, it will be even more barren than today, a monument to the one-way flow of cosmic evolution. On the human level, its silence parallels our own search for meaning. When we look into the Boötes Void, we are confronted by absence on a scale that dwarfs imagination. Yet in that absence, we find questions. And in those questions, we find purpose. The void does not tell us what to believe, but it insists that we wonder. It is here that science and philosophy converge. To a physicist, the Boötes Void is a region of low density, a tool for probing dark matter, dark energy, and neutrino physics. To a philosopher, it is a mirror of solitude, an invitation to reflect on what it means to live in a universe that does not guarantee connection. To a poet, it is silence stretched across 330 million light-years. And to all of us, it is a reminder that emptiness can be as powerful as presence. So what lies inside the Boötes Void? The whispers of neutrinos, the growing pull of cosmic flows, and a reflection of our own search for meaning in infinity. It is an emptiness that shapes both the universe and the human mind, vast, silent, and endlessly profound. Gravity bends light, and usually it does so dramatically in crowded places. In clusters, where galaxies and dark matter twist the paths of photons into arcs and rings. This phenomenon, called gravitational lensing, has been one of astronomy's most powerful tools. But voids tell the opposite story. Instead of bending light inward, they let it drift outward, subtly diluting and stretching images of galaxies that shine through them. The Boötes Void, by its sheer size, is an exceptional stage for this anti-lensing. Light that crosses it may arrive a little fainter, a little stretched, its message altered not by abundance but by absence. Detecting these faint distortions is difficult, but if we succeed, they become a new way to test the shape and expansion of the universe. The void itself becomes a lens, not of magnification, but of release. Such observations also test alternative cosmologies. If gravity is not precisely as Einstein described, or if dark energy behaves differently than our equations predict, those differences should be most evident where matter is missing. The Boötes Void is like a blank page against which the handwriting of physics is most legible. Whether our universe is ruled by standard relativity or something stranger, the answer may be hidden in the distortions of light crossing its darkness. But beyond physics, there is something deeply human about gazing into such emptiness. The Boötes Void is a confrontation with scale, a silence so large that it echoes within us. It sharpens our sense of wonder because it defies the expectation that the universe should be full, vibrant, generous. It reminds us that creation is uneven, that beauty often arises from contrast, and that vast stretches of existence may carry no story but the one we give them. In the end, the void does not diminish the universe's majesty. It expands it. For every cluster we celebrate, every star we count, every filament we trace, the Boötes Void reminds us that the cosmos also speaks through absence, and that absence is just as worthy of awe. So what lies inside the Boötes Void? Light stretched thin by emptiness, a laboratory for testing the laws of gravity, and the sharpening of human wonder when faced with silence on the largest scale imaginable. The universe is always changing, even if the change is so slow it escapes human eyes. Galaxies cluster, filaments stretch, stars burn and fade. And while these luminous processes capture our attention, the future belongs to something quieter, the voids. As cosmic expansion accelerates, voids will not only persist, they will grow. They expand faster than dense regions because they face no gravitational resistance. Over trillions of years, they will merge, swelling into oceans of emptiness far larger than the Boötes Void. What is rare today will one day be the dominant feature of the cosmos. The future universe is not one of clusters and webs, but of deepening deserts. But deserts are never entirely lifeless. Even in the Boötes Void, hidden relics may endure. Clouds of intergalactic gas, faint dwarf galaxies, and wandering rogue stars could drift inside, too dim for us to detect today. These relics would not erase the void's emptiness, but they would soften it. Sparks glowing faintly in a darkness that otherwise feels absolute. Future instruments, more sensitive than anything we have now, may reveal that even the most barren places harbor subtle traces of structure. For scientists, this possibility is more than curiosity. If relic gas and faint galaxies linger inside the Boötes Void, they could answer some of cosmology's most pressing questions. Where is the missing matter the universe's equations predict? How do galaxies evolve when deprived of interaction? How thin can existence be and still persist? The void becomes not an end of discovery but a beginning, an invitation to refine our tools until they can see the nearly invisible. And for humanity, the lesson is symbolic. The Boötes Void is a puzzle in physics, yes, but it is also a metaphor. Emptiness can feel overwhelming, frightening, meaningless. Yet even in the vastest desert of space, there may be traces of resilience. A faint galaxy, a lone star, a whisper of gas. In the same way, even in the darkest stretches of human experience, meaning endures if we choose to see it. So what lies inside the Boötes Void? The seeds of the future cosmos, faint relics waiting to be discovered, and a profound metaphor for endurance. It is both a scientific puzzle and a spiritual reminder that emptiness is not nothing, and that even silence has a story to tell. The universe has a temperature, not the warmth of stars or the heat of galaxies, but the faint background glow left behind by the Big Bang itself. Today, that glow, the cosmic microwave background, chills at just 2.7 degrees above absolute zero. And yet, even that subtle warmth is not perfectly even. Voids like the Boötes Void influence this cosmic temperature field. As photons travel through vast emptiness, they lose and gain tiny amounts of energy, depending on how space expands along the way. The result is that voids act like gentle fingerprints on the universe's thermal map, creating patches slightly cooler or warmer than expected. The Boötes Void, given its enormous scale, may contribute one of the most significant of these imprints, a silent mark left on the background glow of creation. Beyond temperature, the void may also hold the faintest glimmers of background light from ancient times. Long before galaxies filled the sky, the first stars flickered on, emitting ultraviolet light that bathed the young cosmos. Much of this radiation has been absorbed or reprocessed, but some of it may still seep through in regions where matter is scarce. The Boötes Void could thus act as a pristine window, allowing us to glimpse traces of that first illumination, the moment when darkness first yielded to light. And then there is the matter of scale. The Boötes Void stretches across 330 million light-years. To human minds, these distances are almost impossible to process. Our entire history, every civilization, every memory, fits inside a few thousand years. Light itself, racing at 186,000 miles per second, would take longer than multicellular life has existed on Earth just to cross this single void. Confronting that scale changes us. It humbles us, reminding us of our fragility. But it also elevates us, because despite our smallness, we can measure it, describe it, and even imagine what it means. The Boötes Void does not diminish humanity. It sharpens the wonder of what it means to be conscious in a universe so vast. So what lies inside the Boötes Void? A cooling imprint on the background of creation, a faint glow of the universe's first stars, and a scale so vast that it reframes our very sense of existence. It is silence that shapes the cosmic temperature, emptiness that carries memory, and enormity that invites us to see ourselves anew. The cosmos is a restless sea of particles, most of them unseen. Among these, some are unimaginably energetic, cosmic rays that streak across the universe at nearly the speed of light. They are accelerated by violent events: supernova explosions, jets from black holes, collisions of galaxies. But their journeys are rarely straightforward. Magnetic fields twist them, scatter them, confuse their origins. This is where the Boötes Void becomes valuable. In its emptiness, magnetic turbulence is minimal. A cosmic ray crossing hundreds of millions of light-years through this desert of space may travel straighter than anywhere else in the cosmos. For astrophysicists, this means the void is not just absence but clarity, a natural observatory where the universe's most extreme particles may reveal where they truly came from. And then comes the question of hidden forces. The standard model of physics explains much, but not everything. We do not yet understand dark matter, dark energy, or whether new interactions lurk beyond our reach. Voids are prime testing grounds for such mysteries. If unknown forces subtly affect how galaxies move or how light stretches, the effect should be strongest where matter is scarce. The Boötes Void may therefore be a cosmic stage where nature's hidden rules play out in their purest form, undisturbed by clutter. But the void does not challenge science alone. It challenges imagination. Human thought is shaped by contrast, by what we know of abundance. We picture cities, forests, oceans, skies full of stars. Yet the Boötes Void is an expanse where such images fail. It forces the mind to confront scales of emptiness that resist metaphor. It is not a desert, for even deserts teem with life. It is not an ocean, for oceans are rich with depth. It is something beyond analogy, a silence so vast it threatens to outstrip imagination itself. And still we try, because trying is what makes us human. We invent language for the unseeable, metaphors for the impossible, meaning for the seemingly meaningless. The Boötes Void confronts us with a silence larger than comprehension, and our response is not despair, but wonder. So what lies inside the Boötes Void? Straight paths for cosmic rays, a testing ground for hidden forces, and a silence that dares us to stretch imagination until it breaks, only to rebuild it stronger, more curious, more aware of what it means to be alive in a universe this vast. Time is not uniform. It flows differently depending on gravity, on motion, on the very shape of space. In the deep well of a black hole, time stretches, slowing for those who linger near its horizon. But what of the opposite? What happens in a place where gravity is almost absent, where matter is scarce, where emptiness rules? The Boötes Void gives us a glimpse of such a question. In theory, time may tick ever so slightly faster inside a vast underdense region compared to the crowded gravity of a cluster. It is a difference too small for our bodies to feel, yet measurable in principle by the clocks of the cosmos. If so, the void is not just a hole in matter, but a region with its own rhythm of time. A subtle reminder that the universe is not synchronized, but a symphony of varying tempos. This touches the mystery of the cosmic arrow of time, the fact that the universe moves from order to disorder, from low entropy to high. Dense regions, where stars collapse and galaxies collide, accelerate this arrow. They burn energy, create complexity, and increase disorder. But voids like Boötes resist that march. With little matter to rearrange, their entropy rises more slowly. In a sense, they are sanctuaries of stillness, where the arrow of time stretches long and thin, flowing more gently than in the crowded hubs of creation. Could such regions, then, preserve memory longer? Photons crossing the void carry stories from ancient epochs with fewer interruptions, fewer distortions. The Boötes Void becomes a kind of time capsule, not because it is filled with relics, but because it allows signals to pass through almost untouched, bearing the whispers of beginnings across the gulf of ages. Philosophically, this paints emptiness in a new light. We often think of nothingness as erasure, as loss. But here, nothingness is preservation. In its silence, the void protects. In its stillness, it carries the past forward. The Boötes Void is not just a gap in space. It is a keeper of time, a cosmic library where the ink of history is less likely to smudge. And perhaps, in the distant future, when stars have burned out and galaxies have scattered, such voids will be the last custodians of memory. Their emptiness will endure long after light has dimmed, holding the final rhythm of time itself. So what lies inside the Boötes Void? A tempo of time different from our own. A sanctuary where the arrow of entropy slows. And a reminder that even in silence, the universe continues to keep its own kind of clock. Dark energy is the most elusive actor in the cosmic drama. It makes up nearly 70% of the universe, yet we do not know what it is. We see only its effect, the acceleration of cosmic expansion, the stretching of space itself. And it may be in the vast cavities like the Boötes Void where its hand is most clearly visible. In dense regions, gravity resists expansion. Galaxies bind together, clusters form, and local motions complicate the signal of dark energy. But in a void, in a place stripped almost bare, expansion flows unhindered. The Boötes Void may act as a reservoir of dark energy's influence, a natural amplifier where its presence dominates without interference. Measuring how this void grows, how galaxies at its edge drift outward, could give us one of the clearest windows into the true nature of this invisible force. Some physicists speculate that dark energy is not a constant but a field that evolves, like a wind that changes over time. If so, voids may be the places where that wind gathers most strongly, where its fluctuations reveal themselves. The Boötes Void, immense and relatively untouched, could be the perfect stage for detecting such subtle variations. Its emptiness might be less a vacuum and more a container for a field we cannot yet name. Others imagine something even bolder, that voids may connect to hidden dimensions or unseen universes, acting as low-density portals where the fabric of reality is thinnest. This is speculation, yes, but speculation sharpened by the fact that voids are places where our equations struggle, where predictions waver, where the cosmos feels just slightly out of balance. For humanity, the void's lesson is profound. We are used to finding meaning in presence, in stars, in galaxies, in planets. But here, meaning may reside in absence. The Boötes Void tells us that emptiness is not inert. It shapes expansion, influences the fate of galaxies, and perhaps even carries the key to understanding the ultimate destiny of the universe itself. So what lies inside the Boötes Void? The concentrated influence of dark energy, a potential reservoir of evolving fields, and perhaps even the faintest hints that the universe has layers deeper than we can yet imagine. It is not just a hole in space, but a laboratory for the future of cosmology, a silence that may one day tell us how everything ends. On the grandest scales, matter moves like tides. Superclusters draw galaxies inward, filaments stretch across billions of light years, and voids expand outward, draining material from their centers. The Boötes Void, by its sheer size, is not a passive emptiness but an active participant in this cosmic choreography. Its vast cavity tugs at the edges of nearby structures, subtly altering their motion. The surrounding superclusters, Herculean walls of galaxies, grow sharper in contrast because of it. Here, scale teases the imagination. Is the Boötes Void simply a rare coincidence, the result of cosmic chance magnified to an extreme? Or is its size a hint that the laws governing structure formation contain hidden subtleties? Even in our best simulations, voids of this magnitude are unusual. Their existence pushes us to refine our equations, to ask whether our understanding of gravity, dark matter, and dark energy is as complete as we believe. Yet the Boötes Void is more than a scientific puzzle. It is a source of awe equal to any galaxy or cluster. For while galaxies dazzle us with light, the void overwhelms us with silence. Its immensity does not diminish wonder, it magnifies it. Because in its silence, we hear questions louder than answers. In its absence, we feel the presence of possibility. Not nothing. Inside it lies clarity, the stretching of light, the flow of time, the fingerprints of dark energy. Inside it lies history, the faint relics of the universe's first light, the whispers of neutrinos, the echoes of quantum fluctuations magnified to cosmic scale. Inside it lies philosophy, reflections of solitude, resilience, and the human need to find meaning even in absence. The Boötes Void is not an error in the cosmic blueprint. It is part of the design, a pause between notes, a blank space on the canvas, a silence that gives context to the song of galaxies. Without voids, the universe would be cluttered, uniform, unremarkable. With them, it has rhythm, it has drama, it has contrast. For us, the void is a challenge. To measure it is to confront the limits of science. To imagine it is to confront the limits of mind. To interpret it is to confront the limits of meaning. And yet, in doing so, we grow sharper in our curiosity, deeper in our humility, and richer in our wonder. What lies inside the Boötes Void? A reminder that the universe speaks not only in abundance but in absence. That silence, too, is a form of truth. And that even in the deepest emptiness, there is always something profound waiting to be discovered.